Okay, today we're going to do a worksheet on solving simultaneous equations graphically. This will cover for you for your textbook chapter 5.1 and 5.2. Okay, now the basic idea behind 5.1 is we have to draw a graph, okay, a straight line graph. How do I know it's a straight line graph? Because if you notice here, this is x to the power of 1. Same thing here, this is x to the power of 1. If the highest power of x is 1, what we get is a linear or straight line graph. Okay, next thing is this. To draw a straight line graph, we need 2, maybe at most 3 points. 2 is enough, but 3 will enable you to check to see if you made a mistake. Okay, now we have a table of values set up here, so we'll substitute -2 into the equation. So when x is -2, y is equals to -1. So in case you have a problem there, we put -2, okay, plus 1. It is -1. Similarly, when x is 0, y is 1, we get 1. Okay, and finally when x is 2, okay, y is 3. So here is 1 and this is 3. Alright, then now what we do is we simply plot any kind of graphical work. Please do it in pencil. So we have -2, -1 down here, x is 0, y is 1, x is 2, y is 3. Notice that we have 3 points, right, and if they are correct, they should all line up in a straight line. Then what we do now is we will join, okay, the straight line up, and then we label y equals to x plus 1. Okay, what is a graph? Basically a graph, right, shows you all the different combinations or different possible combinations of x and y. For example, for this equation, when x is 3, y is 4. When x is 1, y is 2. When x is -1, y is 0. So basically a graph, right, gives you all the infinite possible combinations of x and y for this equation. Right, so now for b, let's do the same thing as well. We just key in the values. When x is -2, okay, -2, so we put negative sign first, then bracket, -2 for the x, plus 2, okay, y is 4. When x is 0, y is 2. And lastly, when x is 2, y is 0. Okay, we have the 3 points already. Now again we do graphical work in pencil. -2 and 4, x is 0, y is 2, x is 2, y is 0. Okay, all 3 points line up nicely for you, and what I get is y equals to -x plus 2 label. Again, this line will show all the different possible combinations of x and y for this equation itself. Okay, now how do we use the graphical method to solve simultaneous equations? You turn your worksheet to the next page, example 2. So the diagram shows a graph of 2x minus 3y equals 24. So that's already given. On the same axis, draw the graph of x plus y is equals to 2. Okay, before we can draw x plus y equals to 2, let's rearrange the equation. So for part A, so maybe we rearrange to make y the subject. Y equals to 2 minus x. Okay, we need 3 points, so maybe I will start to use, okay, I draw a table first. Okay, when x, we have to choose a few values of x, right? Should we choose negative values of x? In this case, the answer is no, we should not, because if you see, x starts at 0, ends at 13. There are no negative values, so they are not so good in this case. So I should choose positive values. Maybe let me just use something simple, like 0. Okay, 0 is not positive, but 0 is within the scale, so I choose 0, and 1, and 2, like this. So when x is 0, you substitute in the equation, y is 2. when x is 1, 2 minus 1, y is 1. And when x is 2, y is 0. Now we have our table of value. So when x is 0, y is 2. We plot it out there. When x is 1, y is 1. We plot it out there. And finally, when x is 2, y is 0. We plot it out there. Okay, now we join up the curve. We label. Okay, now how we solve them simultaneously is this. We look out for this very special point. This point is the intersection between the two graphs. What is so special about a point is, for this specific value of x and y, where x is 6 and y is -4, it satisfies this equation, and it also satisfies this equation because it lies on the line itself. So basically, the intersection point is the solution of these two simultaneous equations. Because I repeat, this value of x, 6 and y is -4, it satisfies this line because it lies on this line. It also satisfies this line because it lies on the line. So basically, the solution graphically is the intersection point of the two graphs, because it satisfies both equations. So therefore, for part B, I say this: from graph, comma, my x value, okay, let me see my x value. My x value is 6 and my y value is -4. So I write there below, x equals to 6, y equals to -4. And that's how we solve simultaneous equations graphically. And thank you for watching.